Hola guys, we're going to do the geometry semester exam review. Just a couple of tough questions. The rest of them are for you to solve on your own. Here we go. Here we go. Here we go. See. And boom. So we're going to start with question 13. A line and 3 points are shown on the grid. The line on the grid contains points -8, -3, and 4, 1. The point F is located at -4, 4 on the grid. Find the coordinates of 3 points. So we got to find 3 points that lie on the line that passes through point F and is perpendicular to line C. Things that are important here. One big word is perpendicular. Then we see we have these 2 points we have to use. And then they gave you an additional point F. And we're trying to find the line that passes through. First of all, parallel lines are like this, but perpendicular lines intersect. So we need somehow to go find a line that goes through AB somehow. So that's our goal. And thinking about parallel perpendicular lines, that's slope. So we're going to use our slope formula. That is M is equal to Y2 minus Y1 over X2 minus X1. All right, we're going to label our points. I have -8, -3, and then we have 4 and 1. So that will be my X1, Y1 for the first one, and then X2, Y2 for the second one. All right, so we're going to plug them into the formula. So then we have 1 minus -3, and then we'll have 4 minus -8. That gives me 4 over 12. Yeah, 4 over 12, which gives me 1/3. But this word here tells me I gotta do something additional. Perpendicular means almost like the contrapositive. You gotta do the opposite reciprocal. So we need to do the opposite reciprocal of this. So we gotta flip and negate. So the perpendicular slope will actually be -3 over 1. All right? We're gonna apply this slope right here to that point F by using rise over run. So -3 means we need to go down 3 spaces and then go to the right 1. Okay? So down 3 to the right 1. So we're gonna go to F, go down 3. So put your pencil on 3. Here we go. 1, 2, 3 over 1. 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 I'm gonna list all of those points because you need to be able to tell me those points that you just touched. So this first point we have is -3 and 1. The other one we have is -2 and 2. -2. Then this one is -1 and -5. And the one at the bottom we have 0 and -7. But we can also extend our line on the opposite side of F. So on the test, you might be required to find another point on the other side of F. How you would do that is by doing the opposite of this. So instead of going down, because we want to go in the other direction, we could also go up 3, and we could move the negative down here, and that means we'll have to go to the left 1, okay? So go to F and go up 3. 1, 2, 3, and then to the left 1. Leaving us with that point right there, which is -5 and 7. Those are all the possible points for that line. Let's connect it and see what we have. Boom. It's got a little too far there, you know. Boom. That's what we got. So this line is perpendicular to line AB. These are all the possible points. All right, let's move on to 14. 14 is not so tough, but 14 can be a little tricky. So 14, triangle ABC has vertices at A, 1, 2, B, -6 and 4, and C, -5 and -2. What are the vertices of the image of triangle ABC under the translation XY? And then it gives you kind of tells you what to do. X plus 7 and Y minus 5. So translation is one word I see that stands out. We also have vertices, triangle ABC. So they're telling you you're trying to move triangle ABC, and vertices can be the corners of the figure. So there's 3 vertices because it's 3 corners, but 3 angles for a triangle. Here we go. So A is 1, 2. Coordinate 1, 2. Keep it simple. But they're telling you here, let's add 7 to every x and subtract 5 from every y. So you're going to do 1 plus 7, and then you're going to do 2 minus 5, okay? So 1 plus 7 is 8, but 2 minus 5 is -3. That's our first coordinate. You can already see the answer is this one, but I'm going to do one more just so I can show you. So B. B says we have -6 and 4. So let's do it. So they said the translation tells you to add 7 to every x. We're going to shift that. And then we're going to do -5, okay, to every y. So -6, we're going to add 7. And then for 4, we are going to subtract 5. So that should be +1 and then -1. And that's what they have here. All right, let's keep rolling. Pause it if you need to, but I am scurrying on. Boom, here we go. Given in the figure that side AE is congruent to side DE, side EB is congruent to side EC, and side AC and side BD are perpendicular bisectors of each other. Let's just stop right there and let's apply this to the picture. We have these sides that are congruent. So I'm going to just, well, maybe I can keep reading. Right. Based on the information given, which could prove that triangle AEB is congruent to triangle DEC? First, it's a lot happening. So you want to find your 2 triangles that you're working with. They tell you right here. So let's start there. AEB, DEC. So let's find that. A to E to B is there. I can do better. One more time. Okay. So A to E to B is there. Boom. The other triangle is DEC. So D to E to C and back down. Boom. All right, now we're going to apply this stuff right there. So let's see. First, we got to figure out this part. So AE is congruent to DE. So side AE, which is this side, is congruent to DE. And then we have EB is congruent to EC. So EB is congruent to EC. Next we have, so we did this part. AC and BD are perpendicular bisectors. Bisect means to cut it in half. So AC is here, and then we have BD here. So if we're trying to cut that in half, perpendicular lines form those right angles. So we have to create right angles here at the intersection of AC and BD. And then in this triangle as well, you have the same situation. We're going to form right angles, leaving us with side, angle, side congruence. Moving on to the next one, our proof question. In the diagram, it is given that E is the midpoint of AD. Let's just stop there real quick. So E is the midpoint of AD. So you identify where AD is, A to D. They're saying E is in the middle, which means if it's directly in the middle, it means that we can say that these 2 pieces are separated equally, which means this piece, AE, is congruent to ED. Then it says that AB, this symbol means perpendicular. AB is perpendicular to BC. So like we said on the last one, perpendicular lines form right angles. So we got to identify where AB and BC intersect. AB intersects BC right here. That's where your angle is going to be. So we did that. And it says that CB is perpendicular to CD. So perpendicular lines form right angles. So it means this one is CD, and this one is CB, this long side. They intersect and form right angles right here. Like we know that the when 2 triangles touch, when their vertices touch, they create vertical angles. We call it the bow tie. So we got the bow tie situation happening here. There we go. So we have an angle, and then we have a side. So that leaves us with angle, angle, side for our congruence for the 2 triangles. Now, all you do for this is you just basically explain what you did. E is the midpoint that was given. AE is congruent to ED because the definition of midpoint, okay? Angle BAE is congruent to CED because the vertical angles are congruent. That's our arcs here. So we've explained this part. So we have, let's see, that's the angle. This is the angle. That's a side. All right, let's see. And this information was given as well. Let's work on 5, 6, and 7. down a little bit. Boom. So we have here, I try to show you a shortcut. Usually when you're trying to think of what you could respond to the proofs, you can use the corners here. They usually kind of give you a hint on what they were talking about. We do know the congruence was angle, angle, side, so I'm going to fill that in. Both triangles are congruent by angle, angle, side. So we know that one. Here we go. So we're trying to explain why angle ABE and angle ECD are right angles. Well, it also helps us that this is the perpendicular symbol. Perpendicular lines form right angles. All right, then ABE. So angle ABE, we notice there's a right angle there. Then they said angle is congruent to angle ECD. That's right there. So they're saying both of the angles are congruent. They're congruent because right angles, you can say the definition of right angle, I believe. Because they're both 90. We both know there's a right angles, they're 90. So definition of a right angle. All right, beautiful. Here we go. Next. Okay. Don't look at the answer. All right, boom. So the vertices of triangle ABC and the endpoints of DE have integral coordinates. Don't get confused. Integral is just talking about like an integer, just a number. 1, 2, 3, 4, 5, 6, 7, 8, things like that. What are the integral coordinates of point F? So as you see, there is no point F. You have to find point F so that these two triangles are congruent. So first you want to look at what they gave you. They gave you a full, lovely, beautiful triangle ABC here. And you want to figure out how they got their last one. So AB, AB corresponds to DE. So we can figure out how we got from A to B first, and then we can go how they got from D to E to kind of figure out the rhythm of how they ended up down here. So A to B, if I wanted to go from A to B, I went up 1, 2, 3, 4, 5. I went up 5 spaces, okay? So that means that going from D to E, let's see how they got it. They did it. So D to E, they went down 1, 2, 3, 4, 5. They went down 5 spaces. So that's how they did theirs. But we need to find F. So let's figure out how to go from B to C. That way it can help us get to E to F. So B to C. I'm gonna see how the heck I got from B to C. So we can go down 5, 1, 2, 3, 4, 5. Or if you want to, it's not too confusing. We can go to the right first. So let's do that. We can go right, so 1, 2, 3, 4. We went to the right 4. I'll put it over here. We went right 4. So that lands us here, and then we went down 1, 2, 3, 4, 5. Then we went down 5. 1 second.
Asia Lawrence, you're needed to the main office. Asia Lawrence, you're needed to the main office, please.
So how they got from B to C was they went over 4, down 5. All right, so for us, we're going to do the opposite of that. So if we want to go from D to E to F, so they went from D to E. Let's start at E. We can go, instead of going to the right 4, we're actually going to go to the left 4 spaces. So 1, 2, 3, 4. That gets us here. So we're going to go left 4. So 1, 2, 3. 1, 2, 3, 4. We're going to go up 5. 1, 2, 3, 4, 5. That lands us here. That's your new F. Okay? And then we went up 5. That lands us at positive 4, negative 1. I'm going to keep rolling till someone knocks on my door. Here we go. Number 25. Which similarity statement, postulate, or theorem correctly identifies the relationship? You can prove triangles similar. So we're looking for similarity and not congruent. You can use side angle side. Which situation here, we have a side angle and a side. So they both have the same angle, which is good. But now we have to see if their sides are proportional. So we're going to do 8 divided by 10 and see what we get. Then we want to do 20 divided by 25 and see what we get. I'm going to go ahead and tell you. You get 20 for both of those, okay? So yes, it works. The sides are proportional and we have the same angle. So we can assume that these two triangles are congruent by side angle side. How I know it was side angle side, because I literally have a side, I have an angle, and I have a side. All right. Just make sure we're still recording, and we are. All right. Last couple of questions. So, if triangle ABC is similar yet again to ADE, then AB, so this long side here, AB, I'm gonna use a highlighter. This side AB is proportional to AD, which is the little side. All right, now we gotta just figure out the match. So blank corresponds to AE. So AE is this shorter side, and then we gotta figure out the matching piece, which obviously is this longer side, which is AC. Give me 1 second. All right, let's see really quickly. Yes, which one would I like to solve first? We can do number 30 because it does, it's the only one without a picture. It might confuse some people. I'll add this lovely little right angle here for you guys. So an engineer must design a wheelchair ramp for Hampton High. So obviously, you know, a ramp needs to go upward. We know we need a right angle. No matter what, angle of elevation or depression always ends up in the bottom corner. Well, yeah, in the bottom side. The ramp must be 40 feet long. So if you look at the picture, which part looks like a ramp? This one. So 40 goes here. And must go 12 feet above the height of the hallway. So 40 goes here. We're talking 12 feet above something. 12 will go here. What must be the angle of elevation? So the angle we said is here. It always goes at the bottom beside the right angle. Now from here, you label your sides. So this one is opposite side because it's furthest away. That's why it's that. This one is hypotenuse. All right, so we got the opposite side, hypotenuse. If you write out SOHCAHTOA, therefore leaving us with O and an H, which means we're going to use sine. So that'll be sine of x equals my opposite side over my hypotenuse. And since we have x on the inside, we need to do the inverse. X equals sine inverse of 12 over 40. Oh, one thing. So first we need to find the inverse. So that would be, you want to make sure your mode is correct. So right now my mode is in radians. It's incorrect. We want to go over to make sure it's in degree, like it is. Then we're going to do second sine of 12 divided by 40. Leaving me with 17.46. But you can round to 17.5. There we go. All right. So good luck on the exam. That's all I got for you.